In this video, we'll be looking into some more points on thermal stability. Then we will be doing some questions on the basis of the concept that we will be learning in this video and also that we have learned in earlier videos. So let's start. Now we have in the first point we have the comparison between the stability of metal halides. Quite obviously, metal fluorides having the small bond length will be thermally stable, and metal iodides having a larger bond length will be less thermally stable, and hence the order. In the second point, we have the information about the relationship between the polarizing power and the thermal stability of alkali metals and alkaline earth metal compounds, both in case of monoatomic and polyatomic anion. This can be extended to the compounds with p block or d block cation as well. So let us first understand the reasoning behind such trend. Then we will conclude and write what's the relationship between polarizing power and thermal stability. So in the case of monoatomic anion, we have learned that the bond that we need to break in order to decompose the compound is the ionic bond. So as we go down the group, then the bond length increases due to the increase in the size of the atom or cation, and so the thermal stability decreases. So in the case of monoatomic anion, polarizing power and thermal stability are directly related. In the case of polyatomic anion, we have learned that the bond that we need to break is not ionic bond but the covalent bond of the polyatomic anion. So as we go down the group, then polarizing power of the cation decreases, and the cation distorts the anion by a lesser degree, and so the strength of the covalent bonds in the polyatomic anion increases as we go down the group. So in case of polyatomic anion, polarizing power and thermal stability are directly related. Now we can use this relationship to answer several questions where we are asked to arrange the compounds on the basis of their thermal stability. Now let us do some questions so that we can gain confidence that whatever concepts we have learned is really helpful in solving problems. So in the first part, we have to arrange these three compounds. First of all, whenever we deal questions with related to thermal stability, we must check whether we are dealing with polyatomic anion or monoatomic anion, because then we can apply the relationship whether polarizing power will be directly proportional or inversely proportional to thermal stability. So in the first question, we are confirmed that this is the case for polyatomic anion. Now, so the relationship that will be applied here is polarizing power is inversely related to thermal stability. We have learned in an earlier video on polarizing power that d block cations are polarize the anion by a larger degree compared to s block cation. So polarizing power among these compounds will be maximum in case of the compound with Ag. So it will have the least stability. Now we have the competition between s block compounds between Na and lithium. From the table we can observe that as we go down the group, then size increases and polarizing power decreases. So due to a larger size, sodium will have a lesser polarizing power, and so its thermal stability will be maximum, followed by lithium and then finally silver compound. In the B part, we have a straightforward question. First of all, this is the case for monoatomic anion, so polarizing power will be directly related to thermal stability. So as we go down the group from lithium to potassium, size increases, polarizing power decreases, thermal stability decreases. In the C part, we are dealing with polyatomic anion. So as we go down the group from beryllium to barium, size increases, polarizing power decreases, thermal stability increases. In the D part, we see that the size between calcium and barium. So from this table we can derive that between calcium and barium, the size of barium is greater. That means the polarizing power of barium is less. And also now it's a very trick, we can sometimes get deceived that this is the case for monoatomic anion, but in fact this is the case for diatomic anion, where the diatomic anion involved is O2 2 minus. So we will use the relationship polarizing power is inversely proportional to thermal stability. So we are talking about the polarizing power of Ba and Ca. So since Ba is down the group, so its polarizing power is less, so its thermal stability will be greater. In the E part, we have discussed earlier that metal fluorides are most stable thermally, and hence the order. In the F part, we have the case of polyatomic anion, and we are going down the group from sodium to cesium, so the thermal stability would increase. Now for cesium and barium, we know that the size of cesium is greater, so its polarizing power would be less, so its thermal stability would be greater since we are dealing with polyatomic anion. In the H part, from lithium to potassium, as we go, then polarizing power is decreasing, but since we are dealing with polyatomic anion, its thermal stability will also increase. Now in the I part, we have monatomic anion, so here polarizing power and thermal stability would be directly related. Beryllium, having the least size, will have greatest polarizing power and hence maximum thermal stability among these three. In the J part, in the K part, we can deal on similar concepts. In the L part also, we have S block, P block and D block compounds here, Hg having a D10 configuration, Pb having a D10S2 configuration, and calcium having an inert gas configuration. So we can order the polarizing power, and since we know that the S block cation shows the least polarizing power, so its thermal stability will be maximum since we are dealing with polyatomic anion, and this will be followed by P block compound and finally D block compound. So we have dealt with a variety of questions on the basis of the concept that we have learned so far, not only in the last two videos but also the video on polarizing power and the size of the cations. In the next video, we'll deal with color of compounds, which is again a very important topic from which questions are very frequently asked, and then we'll go on to heating effect in subsequent videos.